High math contest has three divisions. One of them is Euler, one of them is Fermat division, and the last one Gauss division. We want to solve last problem of in Euler division there are 25 problems. We want to find last problem of Euler division, last problem of Fermat division, and also last two problems of Gauss division. So let's try. Let's start with Euler division. Okay, let's copy and paste it here. Okay. Let's read the problem. It says Rohan draws three distinct circles on a piece of paper such that no circle touches an edge of the paper. Let n be the number of regions into which they divide the paper. For example, if he draws three non-intersecting circles like this, 1, 2, 3. And there would be four regions. Why? Because like one region, two, second region, third, and fourth region. It is four. Inside the first circle here, inside second circle, third circle, and outside all circles, fourth region. It says how many possible values are there for n. So we found n4, it cannot be less than this. I will explain for you. Look, for 5, in general, it has an important idea. This problem is easy. But in general, when you consider a circle, and for example, it intersects other circle in 1, 2 to m, it has m intersections with other circle, then it passes through how many regions? Through m regions. So it will be the previous number of regions plus m. This circle passes through m regions, so it adds by m. Now, another one, if we can consider second and third circle like this. So here, 1, 2, 3, 4, 5. So 5 is also possible. Now, if we consider like this, how many regions are there now? 1, 2, 3, 4, 5, 6. Okay, so 6 number of regions. Now, let's consider 1, 2, 3. So it will be 1, 2, 3, 4, 5. So here we will see, So I think we should, let's consider the next circle here. Let's move it like this. Okay, now if you pay attention, 1, 2, 3, 4. This one 5, this one 6 and 7. So 7. And the last one is 8, and we want to prove it cannot be greater than 8. Why? So let's calculate this 1, 2, 3, 4, 5, 6, 7, 8. How can we prove it cannot be greater than 8? Because look, first circle you draw, it's obvious that we have two regions. The second circle, it has at most two intersections, because two circles have at most two intersections, so it adds 2 because it passed through two regions. The third circle has at most 4 intersections, so it passed through 4 regions at most. So it will be plus 4, so it is 8. So the answer is from 4 like this when they don't have intersection to 8, and all of them were possible. We found example, and it cannot be greater than 8. We proved here. So it will be the answer 4, 5, 6, 7, 8. Okay. It was last problem of Euler division. Now let's solve this problem of Fermat division. Okay, so try to solve this problem first by yourself. Pause the video. Now let's solve it. Okay, so let's consider some small cases, or for example, first term, we know it is 1 because it's 1 square root of 1. It is square root of 2 is 1 point something, floor of that is 1, square root of 3 is 1, so all of them equal to 1, 1, 1. How many ones are there? The next one is what? Square root of 2. We have 3 ones. Then this one is 2, square root of 3 is 2, up to what number is 2? Up to square root of 8, floor of that is 2. But square root of 9 is what? Is 3. Okay. So as you can see, how many 2's are there? You say, okay, 8 minus 1, or you can say 9 minus 2. So look, 8 minus, let me write for you, 8 minus 2 plus 1. Instead of 8, you can write 3 squared minus 1 minus 2, you can say, sorry. Here I meant it is 4, sorry. It is the square root of 4, 5 to 8. Okay. So it is 8 minus 4 plus 1. So it will be 3 squared minus 1 minus 2 squared plus 1. You can cancel these two things. You will see, okay, 3 squared minus 2 squared. Which, how many 2's are there? 8 minus 3, which is 5. Okay. Now this one. 3 is 2 squared minus 1. Next one is 3 to square root of 15, which is 3. So how many 3's are there? 4 squared minus 3 squared. How many 3's are there? 7. 16 minus 9, which is 7. Okay. So the last thing we should know is square root of 2022 is what point something. I will tell you an algorithm. It is so much useful. If you want to learn important algorithm like this completely, as I said before, feel free to send message to my WhatsApp number in the description and comments. We consider from right 2 by 2s. You say 4 times 4 is 16, 4, 2, 2. 4 times 2, 8. And here, if we say 4, the maximum digit, we should place same digits here. Why it is 8, 4 times 2. The strategy is this. So you say 4, 4, 4 times 4, 16. We have 1 times 32, 33. If you place 5, it will be greater than this. So it will be 44 point something. Because the square root of 2022 is 4 point something, so we can see that we have, for example, 44, some 44. How many 44 are there? Like here. For example, 2 is 3 squared minus 2 squared, 1 is 2 squared. It will be 45 squared minus 44 squared. And we should see in, sorry. Because 2022 is 44, we should say 43. How many 43 are there? Why? Because look, the square root of 2022 is 44 point something is 44. But we don't have all 44s. Okay, so we should see how many 44s are there. So here, if we correct, it will be 44 squared minus 43 squared. And last part, 44. We want to see how many 44s are there. So the first 44 is what? 44 times 44 is 4 times 4, 16. We have 1, 4 times 4, 16 plus 1, 17. So 176. So it was 6, 13, 1, 9, 1. So it starts from, if I want to write the first 44, it will be square root of 109, 1936. It's 44. So it will be 2022 minus 1936 plus 1. Okay? So let's calculate. If you want to write, let me erase this part. We don't need this part anymore. Also, we don't need this part anymore. Let's write the rest like this. Okay. So we can write it like sigma I is from 1 to 43, all terms. I times, how many I are there? I plus 1 squared. Here also you can say 1 minus I squared. Okay. Plus, how many 44 are there? 44 times. So if we consider this part, 12 minus 6 is 6. 1. 11 minus 3 is 8. Okay, and here is 9. 9 minus 9, 0. 0. So it will be what? It will be 86 plus 1, 87. Okay, so it will be 44 times 87. Now, here if we calculate I plus 1 squared, I plus 1 squared, we have a famous identity, you should know this. A plus B squared is A squared plus 2AB plus B squared. Okay. So here it will be I squared plus 2I plus 1. So I squared, this one will be cancelled. So it will be sigma I from 1 to 43. I times 2I squared plus I. Okay. Plus 44 times 87. Now, for calculating this, you say, okay, 2 times 1 squared plus 1 plus 2 times 2 squared plus 2 up to 2 times 43 squared plus 43 plus 44 times 87. Now here, if we consider these numbers, at first we consider these, then we consider these numbers. So if you factor from 2, it will be 1 squared, 2 squared, 2, 43 squared, plus 1, 2 to 43, plus 44 times 87. So pause the video, see, can you calculate this by yourself? For solving this part, you should know two basic identities. The first one is 1 plus 2, 3 to n, equal to n times n plus 1 over 2. The next one is 1 squared plus 2 squared plus 3 squared to n squared equal to n. You should memorize these two identities, n times n plus 1 times 2n plus 1 all over 6. So if we calculate, it will be the first one is 2 times, should use second identity, 43, n is 43, times 44, times 2 times 43 is 86 plus 1, 87, all over 2, all over 6, sorry. All over 6, the next one is 1 to 43 is 43, times 44, over 2 plus 44 times 87. Okay, so if we divide, it will be 22. If we divide by 6, it will be 2, 3. Here we can cancel by 3. 8 plus 7, 15. 2 times 3, 6, 27, 9. Okay, now let me write 43 better here. So we should calculate this part. So first, for example, we can factor from 44. 43 times 29 plus, or let's do something. We can factor from 22. Okay, so because all of them are multiple of 22, let's control y, control y. Okay, so let's, okay, it was 29 when we divide by 3. And if we factor from 22, with 2 times 43, 86 times 29, plus 40, 22, 43, plus 2 times 87, okay? Now we should calculate 2 times 87 is 14, 174, this one 43, this one. And also just check, because maybe we had careless mistake. We don't know last answer is what. But pay attention to not have careless mistake. So 86 times 29, you can say 9 times 6, 54. We have 5, 9 times 6, 72, plus 5, 77. 2 times 6, 12. We have 1. 2 times 8, 16, plus 1, 17. So it will be 4, 9, 14, 2. So it will be 2, 4, 9, 4. And then this part. 3 plus 4, 7, 4 plus 7, 11. We have 2, so this part. 7 plus 4, 11. We have 1, 1 plus 9, 10, plus 1, 11. We have 1, 2 plus 4, 6, plus 1, 7, 2. And now if you multiply by 2 this part, 22 times 2, 7, 11. It's 2, 2, 2 times 7, 14. We have 1, 2 times 2, 4 plus 1, 5. So it's 22, 4, 5. And it will be 2, 4, 6, 9, 5. So it will be 5, 9, 6, 4, 2. Okay, so our answer is this for this problem. Okay. And the problem says find mod 100. Oh. So because we wanted to find mod 100, let me tell you something. You don't need to calculate these things completely. How, let me tell you from this board, when it is mod 100, how you can reach the answer quickly, because the answer is 42, okay? I want to tell you a way to calculate last two digits quickly. So here 42. Now this one. When you want to calculate, for example, 43, 44, 29, when you want to multiply 43 by, for example, 44, you say, okay, 4 times 3, 12. We have 1, 4 times 4, 16. 16 plus 1, 17. You don't need to continue because we want last two digits. Okay, so 7 to 7 to 9 2. So here you conclude it is 9 2. And for example, 22 times 43, you say, okay, 86, and then 6, 6, 4. So it will be 4, 6. And for this one, 44 times 87. So 4 times 7, 28. We have 2. 4 times 8, 32. Plus 2, 34. So it will be 48. 8 again. 8, 12, so it will be 28. Now the last part. So if you add these two numbers, 8 plus 6, 14. We have 1, 4 plus 2, 6 plus 1, 74. 92 times 29. So it will be 9 times 2, 18. We have 1, 9 times 2, 9, 81 plus 1, 82. 2 times 2, 4. So it will be 68. So here also it will be 68. 8 plus 4, 12. We have 1, 7. Okay, we have 4 plus 8, 12. 1, 1 plus 7, 8. 8 plus 6, 14. Last two digits is 42. Also, if you see here, we found 42, but you don't need to calculate completely. Okay, it was last problem of which part? Fermat division. Now let's solve these two last problems. This one is for Gauss part. So the idea I want to use for this problem is useful in many math exams, AMC, AME, caseworks, SMT for Stanford, Harvard, MIT Math Tournament, HMMT. In all exam, BMO for UK, IMO. So casework, it says Alex have 5 different donuts. Each day he eats at least one donut. In how many different ways can he finish his donuts? Okay. So look, we consider the number of days. Number of days. It can be from 1 to 5. 1, 2, 3, 4, 5. Because he eats at least one donut each day. Okay, so if you have one day, he should eat all his donuts in that day one way. There are 2 days, so he can eat 4 1. And 1 4 also will be same, so we multiply by 2. Plus 2 donuts in this day, 3 donuts in second day, or vice versa, 3 2 times 2. So if you have 4 here, which 4? Because it says different donuts. So 5 choose 4 times 1 choose 1. This one will be unique times 2. Plus here 5 choose 2 times 3 choose 3 times 2. So 5 choose 4 is 5. 5 times 2 10. 5 choose 2 10. 10 times 2 20. So it will be 30. Now if you have 3 days, also you can solve with recursive sequence these types of problems. So let me tell you first, for example, 5 4, because they are easier to get good at them, and try to solve 3 by yourself. Pause the video and after that watch the rest of the video. For 5, it's obvious. Why? Because you say, okay, 1, 2, 3, 4, 5. You have one donut each day, so it will be 5 factorial, okay? Which donut in which day, which is 120. When we have 4, one day we have 2 donuts, another day we have 1 donut. Okay, so it will be what? 4 choose 1, which day we have 2 donuts, and which 2 donuts? 5 choose 2, and the rest is 3 factorial. So it will be 4 times 10 times 6, which is 240. And 3 donuts, 3 days. When we have 3 days, the cases are, we have, for example, 3 donuts here, 1 donut, or 2 donuts, 2 donuts, 1. So the first one you say, okay, which day is 3 choose 1, which day he eats 3 donuts. So in that day, which 3 donuts, 5 choose 3, and the 2 other donuts, 2 factorial, plus which day we have 1 donut, 3 choose 1, and which donut, 5 choose 1, and 2 days that are left. In each day, 2 donuts. So first day that has 2 donuts, 4 choose 2. Next one, 2 choose 2. So if we calculate, let's move this part, okay, to have more space. 3 times 10, 30 times 2 plus 3 times 5, 15 times 4 choose 2 is 6, so it is 90. 2 times 30, 60, 60 plus 90, 150, okay? So let's calculate 250 plus 120, sum of them is the answer, is 360. 150 plus 30, 180, 180 plus 1, 181. So if you add 1, 8 plus 6, 14, and we have 1, 1 plus 1, 2, 2 plus 3, 5. So the answer is 541. Look, the idea is this. Maybe, for example, in each problem we have some careless mistake, you can review this. And if you found any careless mistake, comment right below this video to consider. It was second last problem, and one problem is left here, the geometry problem in Gauss division. Let's see how can we solve this. It says triangle ABC has side length AB 15, BC 20, AC 25. If you check, you can see, okay, 15 squared plus 200 squared, 20 squared is 225 plus 20 squared, 400, which is 625, which is 25 squared. And you can understand, okay, these sides are sides of a right angle triangle, and AC is hypotenuse, so B equal to 90 degrees. Okay. It says a semicircle is drawn passing through the points ABC. Okay, so let's draw. Okay, this ABC. Oh, sorry. Let's consider because B is right angle triangle. B is 90, so it is B. It is A. It is AB is smaller. Yes, C. Now, it says two more semicircles, diameter AB. This one was with diameter AC because it's 90. It says we draw two more circles, semicircles with diameter ABAC are drawn from outside the right triangle. Okay, something like this, and it says find the total area that is inside the second and third semicircle, but outside this semicircle, the black one. So you shouldn't consider this part because black semicircle. So it wants the area of this part and this. Okay. So we had similar problem in AMC, but this one is easier than AMC. We know that if you have a circle and the radius is pi, the area is pi r squared. If the radius is r. Now for semicircle is half of that. Now, if you want to calculate the red area, I calculate. Let me show you the green part. So first, let's consider, for example, here, this green part first. Then I calculate because they are semicircle. I can calculate this one, and what is bad? This one is bad. Okay, so we also add this triangle, and then so we considered all these things. So what is bad now? This part is bad. Then we subtract the pink area from these green areas. Okay, the pink area, if I draw, let me show you, it will be something like this. Okay, so the green area, let's consider the radius. This one is 15, so the radius is 15 over 2, which is 7.5, 15 over 2, 15 over 2. This radius is what? The length is 20, so it is 10, it is 10. This one is 25, so the radius is 25 over 2, 25 over 2. So the green area is equal to 1 half pi r squared, 15 over 2 squared, plus 1 half times pi 10 squared plus this area is 15 times 20, the area of right angle triangle over 2, minus if we subtract the pink area, which is 1 half pi 25 over 2 whole squared. Okay, so now let's calculate the area here. We can simplify. The first one is 15 squared is 225 pi over 4 times 2, 8, plus 100 pi over 2, which is 50 pi, plus 2 times this 10, 150, minus 25 is 625 pi over 4 times 2, 8. Okay, now let's simplify as much as we can. 8, 225 pi plus 8 times 5, 50, 400 pi, minus this one 625 pi plus 150. Okay, so as you can see, the sum of these two things will be 625 pi, and they will be cancelled, and the answer is 150. So we found an important rule. Because of Pythagorean theorem means what? AB squared plus BC squared AC squared. The sum of these two semicircles equal to the greater one area of this, so they will be cancelled. So the only thing will be left is area of triangle. So for any right angle triangle, if you consider this area, it is equal to area of the triangle. Okay, so we've solved last problems of these exams for different division. Okay, we have important ideas in geometry, combinatorics, algebra, number theory, calculus. If you want to learn important ideas that are useful for also passing national exams like USAMO, AMC, AME, BMO for UK, PMO for Philippine, SMO for Singapore if you want to learn them, and reach IMO level. As I said before, there are around 40-50 important ideas in each topic. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks for watching this video. See you next time. Bye.